Chapter 7 of Curiosities of the Sky. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Greg Bell. Curiosities of the Sky by Garrett Serviss. Chapter 7. As all the world knows, the sun, a blinding globe pouring forth an inconceivable quantity of light and heat, whose daily passage through the sky is caused by the earth's rotation on its axis, constitutes the most important phenomenon of terrestrial existence. Viewed with a dark glass to take off the glare, or with a telescope, its rim is seen to be sharp and smooth circle, and nothing but dark sky is visible around it. Except for the interference of the moon, we should probably never have known that there is any more of the sun than our eyes ordinarily see. But when an eclipse of the sun occurs, caused by the interposition of the opaque globe of the moon, we see its immediate surroundings, which in some respects are more wonderful than the glowing central orb. These surroundings, although not in the sense in which we apply the term to the gaseous envelope of the earth, may be called the sun's atmosphere. They consist of two very different parts. First, the red prominences, which resemble tongues of flame ascending thousands of miles above the sun's surface, and second, the corona, which extends to distances of millions of miles from the sun and shines with a soft glowing light. The two combined, when well seen, make a spectacle without parallel among the marvels of the sky. Although many attempts have been made to render the corona visible when there is no eclipse, all have failed, and it is to the moon alone that we owe its revelation. To cover the sun's disk with a circular screen will not answer the purpose because of the illumination of the air all about the observer. When the moon hides the sun, on the other hand, the sunlight is withdrawn from a great cylinder of air extending to the top of the atmosphere and spreading many miles around the observer. There is then no glare to observe with the spectacle, and the corona appears in all its surprising beauty. The prominences, however, although they were discovered during an eclipse, can now, with the aid of a spectroscope, be seen at any time. But the prominences are rarely large enough to be noticed by the naked eye, while the streamers of the corona, stretching far away in space like ghostly banners blown out from the black circle of the obscuring moon, attract every eye, and to this weird apparition much of the fear inspired by eclipses has been due. But if the corona has been a cause of terror in the past, it has become a source of growing knowledge in our time. The story of the first scientific observation of the corona and the prominences is thrillingly interesting, and in fact dramatic. The observation was made during the eclipse of 1842, which fortunately was visible all over Central and Southern Europe, so that scores of astronomers saw it. The interest centers in what happened at Pavia in northern Italy, where the English astronomer Francis Baily had set up his telescope. The eclipse had begun, and Baily was busy at his telescope when, to quote his own words in the account which he wrote for the Memoirs of the Royal Astronomical Society, "I was astounded by a tremendous burst of applause from the streets below, and at the same moment was electrified by the sight of one of the most brilliant and splendid phenomena that can well be imagined, for at that instant the dark body of the moon was suddenly surrounded with a corona, or kind of bright glory, similar in shape and magnitude to that which painters draw round the heads of saints." Pavia contains many thousand inhabitants, the major part of whom were at this early hour walking about the streets and squares or looking out of windows in order to witness this long talked of phenomenon. And when the total obscuration took place, which was instantaneous, there was a universal shout from every observer, which made the welkin ring, and for the moment withdrew my attention for the object with which I was immediately occupied. I had, indeed, expected the appearance of a luminous circle round the moon during the time of the total obscurity, but I did not expect, from any of the accounts of preceding eclipses that I had read, to witness so magnificent an exhibition as that which took place. Splendid and astonishing, however, as this remarkable phenomenon really was, and although it could not fail to call forth the admiration and applause of every beholder, yet I must confess that there was at that same time something in its singular and wonderful appearance that was appalling. But the most remarkable circumstance attending the phenomenon was the appearance of three large protuberances, apparently emanating from the circumference of the moon, but evidently forming a portion of the corona. They had the appearance of mountains of prodigious elevation. Their color was red, tinged with lilac or purple. Perhaps the color of the peach blossom would more nearly represent it. They somewhat resembled the tops of the snowy alpine mountains when colored by rising or the setting sun. They resembled the alpine mountains in another respect, inasmuch as their light was perfectly steady, and had none of that flickering or sparkling motion so visible in other parts of the corona. The whole of these protuberances were visible even to the last moment of total obscuration, and when the first ray of light was emitted from the sun, they vanished, with the corona, altogether, and daylight was instantly restored. I have quoted nearly all of this remarkable description, not alone for its intrinsic interest, but because it is the best depiction that can be found of the general phenomena of a total solar eclipse. Still, not every such eclipse offers an equally magnificent spectacle. The eclipses of 1900 and 1905, for instance, which were seen by the writer, the first in South Carolina and the second in Spain, fell far short of that described by Bailey in splendor and impressiveness. Of course, something must be allowed for the effect of surprise. Bailey had not expected to see what was so suddenly disclosed to him. But both in 1900 and 1905 the amount of scattered light in the sky was sufficient in itself to make the corona appear faint, and there were no very conspicuous prominences visible. Yet on both occasions there was manifest among the spectators that mingling of admiration and awe of which Bailey speaks. The South Carolinians gave a cheer, and the ladies waved their handkerchiefs when the corona, ineffably delicate of form and texture, melted in the sight, and then in 2 minutes melted away again. The Spaniards, crowded on the citadel hill of Burgos, with their king and his royal retinue in their midst, broke out with great clapping of hands as the awaited spectacle unfolded itself in the sky. And on both occasions, before the applause began, after an awed silence of low murmur ran through the crowds, at Burgos it is said many made the sign of the cross. It was not long before Bailey's idea that the prominences were a part of the corona was abandoned, and it was perceived that the two phenomena were to a great extent independent. At the eclipse of 1868, which the astronomers, aroused by the wonderful scene of 1842, and eager to test the powers of the newly invented spectroscope, flocked to India to witness, Janssen conceived the idea of employing the spectroscope to render prominences visible when there was no eclipse. He succeeded the very next day, and these phenomena have been studied in that way ever since. There are recognized two kinds of prominences, the eruptive and the quiescent. The latter, which are cloud-like in form, may be seen almost anywhere along the edge of the sun, but the former, which often shoot up as if hurled from mighty volcanoes, appear to be associated with sunspots, and appear only above the zones where the spots abound. Either of them, when seen in projection against the brilliant solar disk, appears white, not red, as against a background of sky. The quiescent prominences, whose elevation is often from 40,000 to 60,000 miles, consist, as the spectroscope shows, mainly of hydrogen and helium. The latter, it will be remembered, is an element which was known to be in the sun many years before the discovery that it also exists in small quantities on the earth. A fact which may have a significance which we cannot at present see is that the emanation from radium gradually and spontaneously changes into helium, an alchemistical feat of nature that has opened many curious vistas to speculative thinkers. The eruptive prominences, which do not spread horizontally like the others, but ascend with marvelous velocity to elevations of 500,000 miles or more, are apparently composed largely of metallic vapors, i.e. metals, which are usually solid on Earth, but which at solar temperatures are kept in a volatilized state. The velocity of their ascent occasionally amounts to 300 or 400 miles per second. It is known from mathematical considerations that the gravitation of the sun would not be able to bring back any body that started from its surface with a velocity exceeding 383 miles per second. so it is evident that some of the matter hurled forth in eruptive prominences may escape from solar control and go speeding out into space, cooling and condensing into solid masses. There seems to be no reason why some of the projectiles from the sun might not reach the planets. Here, then, we have, on a relatively small scale, explosions, recalling those which it has been imagined may be the originating cause of some of the sudden phenomena of the stellar heavens. Of the sunspots, it is not our intention here to specifically speak, but they evidently have an intimate connection with the eruptive prominences, as well as some relation, not yet fully understood, with the corona. Of the real cause of sunspots we know virtually nothing, but recent studies by Professor Hale and others have revealed a strange state of things in the clouds of metallic vapors floating above them and their surroundings. Evidences of a cyclonic tendency have been found, and Professor Hale has proved that sunspots are strong magnetic fields, consist of columns of ionized vapors rotating in opposite directions in the two hemispheres. A fact which may have the greatest significance is that titanium and vanadium have been found both in sunspots and the remarkable variable Mira Ceti, a star which every 11 months or thereabout flames up with great brilliancy and then sinks back to invisibility to the naked eye. It has been suggested that sunspots are indications of the beginning of a process in which the sun will be intensified until it falls into the state of such a star as Mira. Stars very far advanced in evolution, without showing variability, also exhibit similar spectra, so that there is much reason for regarding sunspots as emblems of advancing age. The association of the corona with sunspots is less evident than that of the eruptive prominences. Still, such an association exists, for the form and extent of the corona vary with the sunspot period, of which we shall presently speak. The constitution of the corona remains to be discovered. It is evidently in part gaseous, but it also probably contains matter in the form of dust and small meteors. It includes one substance altogether mysterious, coronium. There are reasons for thinking this may be the lightest of all the elements, and Professor Young, its discoverer, said that it was absolutely unique in nature, utterly distinct from any other known form of matter, terrestrial, solar, or cosmical. The enormous extent of the corona is one of its riddles. Since the development of the curious subject of the pressure of light, it has been proposed to account for the sustentation of the corona by supposing that it is borne upon the billows of light continually poured out from the sun. Experiment has proved, what mathematical considerations had previously pointed out as probable, that the waves of light exert a pressure or driving force which becomes evident in its effects if the body acted upon is sufficiently small. In that case the light pressure will prevail over the attraction of gravitation, and propel the attenuated matter away from the sun in the teeth of its attraction. The earth itself would be driven away if, instead of consisting of a solid globe of immense aggregate mass, it were a cloud of microscopic particles. The reason is that the pressure varies in proportion to the surface of the body being acted upon, while the gravitational attraction is proportional to the volume, or the total amount of matter in the body. But the surface of any body depends upon the square of its diameter, while the volume depends on the cube of its diameter. If, for instance, the diameter is represented by 4, the surface would be proportional to 4 by 4, or 16, and the volume 4 by 4 by 4, or 64. But if the diameter is taken as 2, the surface will be 2 times 2, or 4, and the volume 2 times 2 times 2, or 8. Now the ratio of 4 to 8 is twice as great as that of 16 to 64. If the diameter is still further decreased, the ratio of the surface to the volume will proportionally grow larger, and in other words the pressure will gain upon the attraction, and whatever their original ratio may have been, a time will come, if the diminution of size continues, when the pressure will become more effective than the attraction, and the body will be driven away. Supposing the particles of the corona to be below the critical size for the attraction of a mass like that of the sun to control them, they would be driven off into the surrounding space and appear around the sun like clouds of dust around a mill. We shall return to this subject in connection with the zodiacal light, the aurora, and comets. On the other hand, there are parts of the corona which suggest by their forms the play of the electric and magnetic forces. This is beautifully shown in some of the photographs that have been made of the corona during recent eclipses. Take, for instance, that of the eclipse of 1900. The sheaves of light emanating from the poles look precisely like the lines of force surrounding the poles of a magnet. It will be noticed in this photograph that the corona appears to consist of two portions, one comprising of the polar rays just spoken of, and the other consisting of broader, longer, less defined masses of light extending out from the equatorial and middle latitude zones. Yet even in this more diffuse part of the phenomenon, one can detect the presence of submerged curves bearing more or less resemblance to those about the poles. Just what part of electricity or electromagnetism plays in the mechanism of the solar radiation is impossible to say, but on the assumption that it is a very important part is based on the hypothesis that there exists a direct solar influence, not only upon the magnetism, but upon the weather of the earth. This hypothesis has been under discussion for half a century, and we still don't know just how much truth it represents. It is certain that the outbreak of great disturbances on the sun, accompanied by the formation of sunspots and the upshooting of eruptive prominences, phenomena which we should naturally expect to be attended by action, have been instantly followed by corresponding magnetic storms on the earth and brilliant displays of the auroral lights. There have been occasions when the influence has manifested itself in the most startling ways, a great solar outburst being followed by a mysterious gripping of the cable and telegraph systems of the world, as if an invisible, irresistible hand had seized them. Messages are abruptly cut off, sparks leap from the telegraph instruments, and the entire earth seems to have been thrown into a magnetic flurry. These occurrences affect the mind with a deep impression of the dependence of our planet on the sun, such as we do not derive from the more familiar action of the sunlight on the growth of plants and other phenomena of life depending on solar influences. Perhaps the theory of solar magnetic influence upon the weather is best known in connection with the spot cycle. This, at any rate, is, as already remarked, closely associated with the corona. Its existence was discovered in 1843 by the German astronomer Schwabe. It is a period of variable length, averaging about 11 years, during which the number of spots visible in the sun first increases to a maximum, then diminishes to a minimum, and finally increases again to a maximum. For unknown reasons, the period is sometimes 2 to 3 years longer than the average, and sometimes much shorter. Nevertheless, the phenomena always recur in the same order, starting, for instance, with a time when the observer can find few or no spots. They gradually increase in size until both senses are reached, during which the spots are often of enormous size and exceedingly active. After 2 or 3 years, they begin to diminish in number, magnitude, and activity until they almost or quite disappear. A strange fact is that when a new period opens, the spots appear first in high northern and southern latitudes, far from the solar equator, and as the period advances they not only increase in number and size, but break out nearer and nearer to the equator. The last spots of vanishing period, sometimes lingering in the equatorial region after the advance guard of its successor has made its appearance in the high altitudes. Spots are never seen in the equator nor near the poles. It was not very long after the discovery of the sunspot cycle that the curious observation was made that a striking coincidence existed between the period of the sunspots and another period affecting the general magnetic condition of the earth. When a curved line representing the number of sunspots was compared with another curve showing the variations in the magnetic state of the earth, the two were seen to be in almost exact accord, a rise in one curve corresponding to a rise in the other, and a fall to a fall. Continuing observations prove that this is a real coincidence and not an accidental one, so that the connection, as yet unexplained, is accepted as established. But does the influence extend further, and directly affect the weather and the seasons as well as the magnetic elements of the earth? A final answer to this question cannot yet be given, for the evidence is contradictory, and the interpretations put upon it depend largely on the predilections of the judges. But, in a broad sense, the sunspots and the phenomena connected with them must have relation to terrestrial meteorology, for they prove the sun to be a variable star. Reference was made a few lines above to the resemblance of the spectra of sunspots to those of certain stars which seem to be failing through age. This in itself is extremely suggestive, but if this resemblance had never been discovered, we should have been justified in regarding the sun as variable in its output of energy, and not only variable, but probably increasingly so. The very inequalities in the sunspot cycle are suspicious. When the sun is the most spotted, its total light may be reduced by 1,000th part. Although it is by no means certain that its outgiving of thermal radiations is then reduced, a loss of 1,000th of its luminosity would correspond to a decrease of 0.0025 of a stellar magnitude. Considering the sun as a star viewed from distant space, so slight a change would not be perceptible. But it is not alone sunspots which obscure the solar surface. Its entire globe is enveloped in an obscuring veil. When studied with a powerful telescope, the sun's surface is seen to be thickly mottled with relatively obscure specks, so numerous that it has been estimated that it cut off from 1/10 to 1/20th of the light that we should receive from it, if the whole surface were as brilliant as its brightest parts. The condition of other stars warrants the conclusion that this obscuring envelope is the product of a process of refrigeration, which will gradually make the sun more and more variable until its history ends in extinction. Looking backward, we see a time when the sun must have been more brilliant than it is now. At that time it probably shone with the blinding white splendor of such stars as Sirius, Spica, and Vega. Now it resembles the relatively dull Procyon. In time it will turn ruddy and fall into a closing cycle represented by Antares. Considering that once it must have been more radiantly powerful than at present, one is tempted to wonder if that could have been the time when tropical life flourished within the earth's polar circles, sustained by vivific energy in the sun which it has now lost. The corona, as we have said, varies with the sunspot cycle. When the spots are abundant and active, the corona rises strong above the spotted zones, forming intense beams or streamers which on one occasion at least had an observed length of 10,000,000 miles. At the time of a spot minimum the corona is less brilliant and has a different outline. It is then that the curved polar rays are most conspicuous. Thus the vast banners of the sun, shaken out in the eclipse, are signals to tell of its varying state, but it will probably be long before we can read correctly their messages. End of chapter 7. Recording by Greg Bell.